Welcome to this explainer. Today we're diving into one of the absolute most massive, multifaceted challenges facing our world right now, water scarcity. We live on a planet that literally looks blue from space, yet we're somehow facing a mounting crisis of dry taps and empty wells. Why is that? To really wrap our heads around this issue, we're going to map the whole problem out holistically. Part 1, the scarcity paradox. Part 2, drivers of the crisis. Part 3, the promise of dams. Part 4, the price of dams. And finally, Part 5, the harvesting alternative.
So let's jump right into Part 1, the water scarcity paradox. A blue planet drying up.
Let's start with a completely baffling contradiction. 2 billion. Just let that number sink in for a second. By the year 2025, that is the prediction for how many people will live in absolute water scarcity. That's a massive, massive portion of the global population facing a daily reality where there simply is not enough water to meet their most basic needs.
Which begs a pretty obvious question, right? How on earth do we run out of a renewable resource? I mean, 3/4 of our planet's surface is covered in water, and we know from basic science class that it's constantly renewed and recharged through the hydrological cycle. So we really have to ask ourselves how a shortage of this magnitude is even possible when, technically, the cycle keeps water renewable.
It's a brutal irony, really. You can have a situation where a boy is navigating severe floodwaters in Calcutta after a massive downpour, literally surrounded by water in every direction. Meanwhile, in another region, women are standing in incredibly long lines with earthen pots just to secure their daily drinking water. Being surrounded by water definitely doesn't mean you have water you can actually use.
That brings us to Part 2, drivers of the crisis. What's putting all this pressure on our water?
The reality here is that water scarcity is rarely just about a lack of rain. It's almost always about human overexploitation. Believe it or not, irrigated agriculture is our single largest consumer of water, mostly to keep dry season farming alive. Then you factor in rapid industrialization. Actually, fun fact, about 22% of India's electricity comes from hydroelectric power alone. Add our dense, rapidly multiplying urban centers that are just relentlessly pumping out groundwater, and finally, bad quality. Even when water is totally plentiful, severe pollution from chemicals and waste is turning rivers into toxic streams, making them completely hazardous to use.
Moving on to Part 3, the promise of dams and those grand mega-project solutions.
So how did governments historically try to solve these intense pressures? Well, they went big, grand, mega-project solutions. But to really understand these massive engineering feats, it's crucial to clarify what a dam actually is. We usually just picture a giant concrete wall, but the term primarily refers to the massive reservoir, the artificial lake that the wall creates. It's all about capturing and controlling the flow of a river to serve our human needs.
Post-independence, the optimism around these projects was just off the charts. Jawaharlal Nehru even famously called them the temples of modern India. These multi-purpose river projects were viewed as the ultimate vehicle for progress, designed to seamlessly integrate agricultural and village development with rapid, booming industrialization.
But of course, that leads us to Part 4, the price of dams and their unintended consequences.
As with any massive intervention in nature, there is a serious cost. Ecologically, damming severely disrupts natural river flows. This starves floodplains of the fertilizing silt they need and traps excessive sediment at the bottom of the reservoirs. It literally fragments rivers, making it basically impossible for aquatic fauna to migrate and spawn. Entire local ecosystems are just submerged and left to decompose. And, quite ironically, the shift to water-intensive commercial crops that these dams made possible has actually led to massive soil salinization, essentially degrading the land itself.
Beyond the ecological toll, there's a very stark human element here. If we look at who actually benefits from these megaprojects, it tends to be landowners, growing urban centers, and big industry. But the cost? That is almost entirely borne by local, often landless communities who are displaced. They lose their land, their livelihood, and their access to basic resources. If the locals giving up absolutely everything aren't benefiting, we really have to ask ourselves, who is actually reaping the rewards?
And that exact clash of interests between development and displacement has sparked some intense social and political friction. For example, you have the Narmada Bachao Andolan, an NGO movement that mobilized tribes, farmers, and activists to fight for rehabilitation after being displaced by the Sardar Sarovar Dam. We also see incredibly complex interstate disputes. Take the Krishna Godavari dispute, where states like Karnataka and Andhra Pradesh have strongly objected to water diversion by Maharashtra out of fear it would ruin their own downstream agriculture and industry.
Which brings us naturally to Part 5, the harvesting alternative, going back to traditional solutions. Because of all the extensive controversies and astronomical costs tied to megadams, a lot of regions are pivoting right back to highly effective traditional solutions. Look at this incredibly ingenious step-by-step system used in the semi-arid regions of Rajasthan to securely collect rainwater. Basically, the rain hits a sloping roof, travels down a pipe, and crucially, that very first rain is allowed to just flush out and clean the whole system. Then the next batch of rain, the pure water, is stored in an underground tanka. This harvested water, locally called palar pani, is considered the purest form of natural water and provides a totally reliable drinking source even in the absolute dead of summer.
And we're seeing this amazing blend of ancient wisdom and modern necessity popping up all over. In Meghalaya, there's an incredible 200-year-old system that uses bamboo pipes to transport spring water over hundreds of meters, delivering precise little drops directly to plant roots. Down in Karnataka, the remote village of Gendathur has adapted rooftop harvesting so successfully that they're uniquely famous for being rich in rainwater. And in Tamil Nadu, they've actually gone a step further and made rooftop rainwater harvesting legally compulsory for every single house across the entire state.
So as we wrap up this explainer, I want you to take a second and think about the hydrological cycle flowing directly into your own home. Where does your tap water actually come from? Is it pumped from a distant megadam, drawn from a local aquifer, or maybe harvested from the rain? Ask yourself how your local community balances those precarious scales of abundance and scarcity. Understanding that local connection is the very first step in ensuring our blue planet doesn't actually run dry. Thanks so much for joining me on this deep dive, and keep asking questions about the world around you.